Okay, we're going to be looking at finding probability and odds. An outcome, you can see some definitions here. An outcome is a possible result of an experiment. Events is an outcome or a collection of outcomes. Sample space is the set of all possible outcomes. For example, it says you flip a coin and you roll a die. How many possible outcomes are there in the sample space? Well, let's list them all. Well, I could roll a die, I could roll a 1, and then when I flip the coin, I could get heads on when I flip the coin. Or I could roll the 1 and I could flip the coin and I could get tails, right? So those are two different possible outcomes. I could roll the die and get a 2 and then get a heads. I could roll a 2 and get a tails. I could roll a 3 and get heads, or I could roll a 3 and get tails. I could roll a 4 and get heads, or I could roll a 4 and get tails. I could roll a 5 and get heads. I could roll a 5 and get tails. I could roll a 6 and get heads. I could roll a 6 and get tails. So, how many different possible outcomes are there? 2, 4, 6, 8, 10. There's 12 different outcomes that I could get when I roll the die one time and I flip a coin and determine what I get. Okay? Those would be the possibilities. Now, we're going to look at what's the probability of an event happening. In other words, what's the probability that I roll a 3 and get a tails? Okay, well, the probability of that happening is going to come down to your favorable outcomes, which is what you want to happen, divided by your total number of outcomes. Okay, probability of an event is a measure of likelihood or chance that an event will occur. It's a number from 0 to 1. So there's different ways to list probability. We're going to do it as fractions, okay? But I could take that fraction and I could rewrite it as a decimal, or I could change it into a percent. And that's why we see probability is from 0 to 1, because that decimal of probability happening, if the probability of something happening is 100%, or 1, okay, 1 is the equivalent to 100%. Most often, probability of something happening is like 50%, you might say, or so many percent. Well, that's a decimal that's less than 1. So we say between 0 and 1. Favorable outcomes are the outcomes that you desire to happen. So, for example, if I went back up here and I said, what is the probability of an event happening? We use probability P. So if I said, what's the probability of rolling a 3 and tails, okay, something like that, then how many times up here does that happen? That's my favorable outcome. How many times up here did that happen? Well, there's only one time up here that happened. And how many different ones did we say? How many possibilities are there? We said there were 12. So I have a 1 in 12 chance of rolling the 3 and flipping the tails on the coin. Okay? So theoretical probability is, I didn't actually do it, but in theory, the probability is the number of favorable outcomes, that's what you want to happen, divided by the total number of possible outcomes. Okay? Let's see what else we have here. For example, 2, it says you and your friends designed t-shirts with silk-screened emblems and you are selling the t-shirts to raise money. The table below shows the number of t-shirts you have in each design. A student chooses a t-shirt at random. What is the probability that a student chooses a red shirt? Okay, well, how many total red shirts do we have? Okay, we have some with gold emblems and we have some with silver emblems, but they're both red shirts. So favorable outcomes would be those that are red divided by the total outcomes, which would be all your shirts together. So the total red shirts is 12. And then how many shirts do we have all together? Well, we have 10 and 8. That's 18 green ones. So 18 total green shirts plus the 12 total. There's a total of 30 shirts. So 12 out of 30. And again, anytime you work with fractions, you want to reduce fractions. So I wouldn't leave it as 12 over 30. But 6 will go into 12 twice, and 6 will go into 35 times. So I'd say that my probability is 2 out of 5. It says, what is the probability that a student chooses a t-shirt with a gold emblem? So gold emblems, Okay, it doesn't say what color it has to be, but it just has to have a gold emblem. There's 16 of those that are favorable, what we want, and there's still a total of 30 types of t-shirts. So I'd start with 16 out of 30, and then I want to reduce that down. If I divide them both by 2, I get 8 over 15. So 8 over 15 is my probability of selecting a t-shirt with a gold emblem. Okay, experimental probability is a little bit different. It's based on repeated trials. So if I actually had you roll that die and flip that coin and you had some data with which to look at, that would be your experimental probability. Okay, so experimental probability is slightly different. It's just the number of successes or the number of favorable outcomes divided by the number of trials. But you're going based on what you've actually done, what your data is. Okay, so it says each section of the spinner shown as the same area. The spinner was spun 20 times. For what color is the experimental probability of stopping on the color the same as the theoretical probability? Well, we've got 1, 2, 3, 4 different colors. They're all likely, right? They should all be equally likely theoretically. So I should have a 1 in 4 chance for each color, which would be the same if I spun it 20 times. That would be 5 out of 20 times I would get that color. Okay, so which one is actually met that results? I would say red. Red actually met the results. And it says use the outcomes of the table to find the experimental probabilities. For red, it was 5 out of 20 times, or 1/4. For green, it was 9 out of 20 times. That doesn't reduce, so I just leave that. For blue, it was 3 out of 20. That doesn't reduce, so I'll leave that. And yellow was also 3 out of 20. Okay, so we can, when we're doing experimental probability, we just go ahead and use the data that we were given rather than the theoretical. But since there were 4 different colors, they're all equally likely. You'd have a 1 in 4 chance for each one. So it was red that came out to be closest to that. Okay, now when it comes to odds, odds are slightly different than probability. Odds, it says compare the number of favorable and unfavorable outcomes. So we don't use the total number of outcomes on the bottom when we're looking at odds. We use the unfavorable. Okay, so odds in favor of something happen, it's the favorable outcomes over the unfavorable outcomes. Okay, using the spinner from the previous example, find the odds of against stopping on green. Oh, and you've got to be careful with the wording here. Okay, so let's go back up and look at green. I'm going to actually do the letter B first here because I don't like the wording is going to be important. It says the odds in favor of stopping on blue. Well, how many times did it stop on blue? 3 times, which instead of using the total or 20, that means how many times it's going to be favorable to unfavorable. How many times did it not stop on blue? Well, if we spun it 20 times and 3 times it landed on blue, that means 17 times it landed on a different color. So the only thing that's different is instead of using the total here, okay, you use the 2 should add up to the total spun. It's favorable to unfavorable. Now, odds generally aren't listed as a fraction, although you can. Typically, we see odds listed with a colon, where the first number is what you're desiring to happen, and your second number is the unfavorable. Okay. Now, here's where it gets tricky. It says the odds against stopping on green. Well, if it against stopping on green means favorable is when it didn't stop on green. Okay, well, it stopped 9 times on green. That would be the unfavorable. That means that there's 11 times that it didn't stop or against stopping on green. So that would be 11 to 9. Or you wanted the fraction 11 over 9. Okay, and again, just like we would reduce a fraction, if you're going to write it with a colon, you would want to reduce that as well. Be careful with your reading. Okay, and then example 5, according to the meteorologist, there's a 60% chance that it will rain today. What are the odds in favor of rain? So if it's a 60, so 60% is it's favorable, so it would be 60. That means what's the percent that it's not going to rain today, or what's unfavorable? And that would be 40. Or you could say 60 over 40, and we would reduce that. Okay, we could reduce that with 6 over 4 by canceling a 0, and then that still reduces down. 2 goes in there 3 times, 3 over 2. So my odds of it raining is 3 to 2. You could leave it like this, and it would still simplify down 3 to 2. Okay, so go ahead and start on that worksheet, and then when everyone's done with their quiz, we'll answer questions.